I want to quickly get this out of the way before I actually cover integration by substitution, which is what I really want to teach today, okay? But it's just a minor note of sort of like how do you explain your answer for this, and in the bookmarks that I've seen, that I've marked already, I think 3 or 4 of them, there's all kinds of different ways to do it. I just want to give you the way that would be, most correct, okay? So I'm going to do 4A and 4B with you, right? Now I'm calling these symmetrical areas, even though if you read the question, I believe question 4 says, in each of these areas, you'll need to calculate the shaded area by calculating 2 areas, okay? Now, we're going to use that as our starting point, okay? But as you can probably imagine, that is not a very efficient way to do it, right? Now, this shaded region here, underneath these 2 graphs, is what we're trying to calculate, okay? The first thing you may want to watch out for is that I think in your exercise, these 2 equations, I think they're swapped around, which might be confusing. So if you got like 128 or something like that instead of 16 or 3, that would explain why. So blame Cambridge, but anyway. How do we, now that I've got them the right way around, how would I express this area in terms of 2 integrals, okay? Now let's go from left to right. What will be the first one? How would we define this area? Good, so our lower bound will be -2. I'm just going left to right, okay? And it's going to end at 0. It ends at 0 because, getting another color out, this is where I started, okay? So far, I'm still under the same function, and then here, it changes over, okay? At that point 0, at the origin, at the y-axis, I'm no longer calculating the area under this curve anymore. I'm calculating the area under a different curve, okay? So that's why my boundary stops, -2 to 0, okay? Then I'm going to stick in this equation, so x plus 2 squared, and I'm looking for the area bounded with the x-axis. So that's why I go dx. Okay? There's the first area. What's the second one? Good. 0 to 2 of, and it's just the other one. Yeah. So no problems here. Now, this is the way the textbook wants you to do it. And it's not a bad way, it's just inefficient, okay? Because it's symmetrical, right? And here's the tricky thing, right? It's symmetrical, but it's not the kind of symmetry that we've already been dealing with under those properties of definite integrals we looked at before. Because this is not an even function. It's not even one function, it's 2 functions, right? So the symmetry doesn't come from the fact that it's even function, right? So I can't say on the next line it's equal to something, something, something as it's an even function, because these aren't even functions, and the whole thing taken together is not an even function. So what am I going to do? Well, I'm going to still write down the same thing. It's a double of a particular area, and I can choose either side, right? Which side do you think you would choose? Probably the one without the negatives in it, okay? I mean, mathematically it's going to be the same, but this is just going to have a double negative in it, that's all, okay? So I'm going to double this area here, okay? But I can't just go from 2 integrals which are completely different and then say, well, I'm going to choose to double one of them. I have to explain, I have to justify why I'm taking this one and calculating it twice, okay? Now, what is the reason? Well, it's about symmetry, right? So I'm going to say by symmetry. Okay, but this is not enough. I need to explain what kind of symmetry it is, right? And when we do 4B, you'll see why this is so important. This area, right, the one that I've worked out, where is the axis of symmetry for the area? It's the y-axis in this case, right? So the way I would say that is about, what's the equation of the y-axis? It's x equals 0, right? Okay, so this is a critical line. It's what allows you to justify making the maths so much nicer and easier. Okay, so that's kind of the part that I was looking for, really. It'll save you from, people will say, going from this line to this line, they'll be like, but why? Okay, and this is the y. Now you can just go ahead. What's this? This is x minus 2 cubed, divide by 3, evaluate the limits, and off you go. And I think you guys are fine from there. Okay, I think from memory you'll get 16 on 3, I think. Which is 5 1/3. But, yeah.
I've gone into, but if you add, if it's x plus 2 and x minus 3,
yeah.
how much just becomes x minus 2?
Ah, yes, right. That's exactly the right question, right? Why is it that, I've got +2 here and -2 here? Why is it just sort of, what happened to this guy? And the answer is, I could choose, because it's symmetrical, I can choose whichever one. So I'm just going to choose the one that's convenient to me, namely where I don't have negatives in it. That's all. Okay? All right, question. You mean not write down this line? Okay. Now, probably yes. Would I do it? No. Because again, what am I after, right? I'm after, as a marker, looking to see if this student can demonstrate understanding of what the question is about. Okay? Now, could you jump to here if you had a good diagram? Yeah, probably. Okay? But this isn't actually the area I'm trying to work out. This is the real area. It's from -2 to 2, and it's this function in this domain, and so on. Okay? So I think this is a safe way to go about it. Could you, if you were in a hurry, could you chop that off? Probably. Okay? But at least for my sake, I'm going to write it down. That'll sort of save me from making errors later on. What if I wrote this down first, but I got it wrong? Like I got this equation wrong or something like that, and I've got no way to go back and check if I had it right or not. Okay? So, probably. Okay, now let's quickly look at the next question. And I foolishly didn't bring my booklet with me, so I'm going to pinch someone else's. Let's look at 4b. Okay? Okay. No, as in the one just after this. Okay. Now, by the way, to say, whoa, that was a good catch. To say by symmetry, it's vitally important you actually have a diagram there, okay? Because otherwise it's like, well, where is the symmetry, right? It's a little bit like saying from the graph, which is why I've drawn mine. I know you've got your question there, okay? But let's have a look at the next one, right? Now, again, yeah, totally different question. I'm going to write the area first in terms of the two equations, the two actual integrals, okay? So I think the first one, they've provided the point of intersection, right? So it starts at the origin, it goes up to 3 on 2, right? And that's just the your standard old boring parabola, okay? X dx, right? Your second area, it takes over at 3 on 2, and then it goes all the way until 3, okay? What's the equation? It's like x minus 3, I think, squared. Does that check out? Yeah. Okay, now, again, I get to choose which of these integrals I'm going to, which of these areas I'm going to double. So obviously, in this case, the one you would choose is the first one, right? Number 1 because it's got less terms, and number 2 because it's got a 0 in it, so it'll be nice and easy to evaluate. So I'm going to do this. And then again, I've got to include this. Right. Now, it's not symmetry about this anymore. It's completely different, right? It's been moved over, it's been shifted, right? So I have to say, by symmetry, about, and then name the axis. Okay, so vitally important that you get that step in. Sometimes you won't actually have to, you'll have to calculate that because they won't just provide you the point. And then you can keep going from there. So this is 2 outside of that, from 0 to 3 and 2, and so on. You go from there. Okay? So please make sure you include that line, it's really important.